So now let's talk about the second type of macromolecules, lipids. So lipids are the only macromolecule that have no special monomers or polymers. Okay, so there is no real polymerization or hydrolysis happening in lipids. Okay, we are also going to understand that lipids are basically fat or oil. The difference between fat and oil is that fat is a solid at room temperature, while oil is a liquid at room temperature. Does that kind of make sense? Cool. All right. Also, understand that lipids are made out of carbon, hydrogen, and oxygen. It's CHO, but it doesn't really have a very special formula like carbs do. Okay? And understand that basically lipids is just a very long chain of carbons and hydrogens, and you'll see this very often. Also, we have two different types of lipids. The first type is phospholipid, which you are very familiar with when you were studying your cell membrane, and number two, cholesterol. And also, we are quite familiar with this word. Okay, good. So now let's continue. Let's talk about phospholipids. So phospholipids are going to look like this. Okay, now this top part is called a head, and the head is actually polar. If something is polar, it's just like water, so it actually likes water, so we call this hydrophilic. All right, and a very popular molecule that makes up the head is called the glycerol. Okay, the glycerol is made up of carbon, 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 and some OHs, OH, H, 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 but here we have hydroxides. So on hydroxides, we can actually add extra stuff to it. Okay, we can add another molecule here, we can add another molecule here, another molecule here. Now these two molecules are basically the fatty acid tails right here. These are the fatty acid tails. Now the fatty acid tails are non-polar. This is what's going to give phospholipids the oily type of, or the fatty type of property. This is also called hydrophobic because it hates water. Okie dokies? Now, we happen to have three different types of phospholipids that you will become accustomed to. One that looks like that, one that looks like this, and one that kind of looks like this, right? So a lot of times you'll see this in micelles, okay? This in cell membranes, right? And these in triglycerides in the adipose tissue, okay? So I can do a whole video on just micelle, cell membrane, and triglycerides some other time, but I just want you guys to understand that we can have three different versions of phospholipids. Good? Good. All right, now let's continue. Let's talk about the types of fatty acid tails. So fatty acid tails can come in two flavors. They can come in the saturated version or the unsaturated version. Okay, when we say saturated version, we are talking about them just having single bonds between the carbon molecules. So these are all single bonds. So we call these are all single bonds. And if you look at them, they're so tightly packed with each other that you look at them, it's like, it's so fatty, right? But the unsaturated version, there's going to be some type of a double bond. So you can have either a double bond or even a triple bond. But most of the time, it's going to be a double bond. Now, if you guys remember from Orgo, single bonds, if you look, right, it's trans. So this is why a lot of times we talk about trans fat, but we never really talk about cis fat. Do you know what I mean? Because if you look at the unsaturated portion, okay, to begin with, we have this little area with the double bond, which we call a kink. But I want you guys to also notice that there's a lot of empty space in between the fatty acid tails. So this is going to allow for less fatty acid tails to fill the same volume. So if you look at this versus this, even in the same surface area, the first saturated one, you can hold up to 4 fatty acid tails, whereas this one, you can only hold up to 2. So there's less fat that you're holding. Does that kind of make sense? Good. So a lot of times when you are, studying your cell membrane, imagine these are all ballerinas with their straight legs, but there's one ballerina that wants to show off, and she's got her leg up, okay? When she has her leg up, obviously that's the little kink that we're talking about. It makes the cell membrane very, very fluid, allowing for particles to pass through, because while she's twirling with her leg up, all the other ballerinas are going to kind of move away from her, allowing for extra space in between this line of ballerinas, right? Allowing for extra space for solutes to pass through. So the more unsaturated fatty acid tails you have, more fluid your cell membrane is going to be. Good? All right, so now let's quickly talk about the second type. So the first type was phospholipid, and the second type is cholesterol. So cholesterol is basically a hexagon looking molecule. So this is the root molecule, and it's got some extra molecules sticking out. I know this is not really what, the molecule is supposed to look like, but I want you guys to just understand that these are all variables. The black hexagons that I've drawn, these are the root molecules, okay? And everything that kind of sticks out, and the double bonds that may exist, and extra stuff that kind of, sticks out, these are all variables. And the variables are there for us to understand that the cholesterol molecule is associated with steroid hormones. And steroid hormones, okay, the main ones that we have to remember are the 3 sex hormones. Okay? And the 3 sex hormones happen to be testosterone, okay, estrogen, and progesterone. So what I want you guys to remember is anything that ends in "-one" is going to be a steroid-derived molecule, okay, or a cholesterol-derived molecule. So this is going to kind of save you later on when you see a molecule that you've never seen in your life and you're like, what the heck is this? Suffixes and prefixes are definitely going to be saving your lives. So just understand, anything that ends in "-one" are cholesterol-derived, okay, and cholesterol is a fat. Good? Good.